Hello, my name is Christian Valdez. I'm from Group 23 and I'll be starting this presentation off of our desired product, the Thirst Quencher. Water makes up a majority of our body weight and is involved in many important functions such as excreting waste from your body, regulating water homeostasis, and lubricating your organs and our body tissues. So we need a constant supply of water to replenish body fluids lost throughout the day through physiological activities such as respiration, sweating, and urination. And unfortunately, many of us do not have a way of tracking how much water we actually consume in a day. That is why we bring to you the Thirst Quencher. Users should be able to keep track of the amount of water they are consuming seamlessly and effortlessly without getting bogged down by manually writing down and calculating measurements on their notepad or someone constantly reminding them to drink water every day. We are limiting the scope of our solution to something that is stationary as to a portable water dispenser, which is specialized to a small user base. Our design challenge is to provide users with a smart water dispenser that keeps track of an individual's water intake and reminds them when they are unable to reach that 8 cups a day quota. The requirements we need for this automated water dispenser is that it must first of all dispense water from an input supply, which is just a big water bottle, to an output container, which could be a water bottle or a glass. The display must also show the amount of water consumption in milliliters, cups, gallons, and ounces. Another requirement is that it must remind the user to successfully finish a cup of water every day through the means of a light or a buzzer. And finally, it must have a working stop button as a safety precaution if something doesn't work out properly in the system. And some of the constraints that we have limited ourselves to is that the water source must only come from a large water bottle as to having a large water supply, say a tap water. This is because we're only planning to use a small tube to transfer water from the input water supply to the output water container. The placement of our system must be stationary and not be brought from one place to another continuously, which is because of our dimension and size constraint. The dimension of our system must be around 20 to 30 to 40 centimeters, which is just enough to hold the output water bottle and store the input water supply. The operating region of our system must be around 7 to 49 degrees Celsius, which is just around tap water operating temperature, which goes from cool to hot water. The operating time of our system must range from 12 to 24 hours, which is just enough to track an individual's water consumption throughout the day. And finally, we have limited our cost to less than $200, which is something everyone could contribute to and afford.
Hello, I'm Josh DeBall, and I'll continue the presentation with the system block diagram. The overall architecture revolves around the ultrasonic sensor detecting the water levels and the change in water levels and tracking this information within the Arduino. The ultrasonic sensor will detect the water levels for logic and implement it in the Arduino. The Arduino will communicate with the hardware, and the software algorithm will be used to store water levels and water usage. The display will give the user information about their water usage and additional functionalities that we may decide to add later on. The power supply with batteries will be connected to the Arduino to supply it with power. The switch will control the motor which pumps the water through the dispenser. All of the blocks are found from the Arduino kit or ordered from Amazon, meaning that they're pre-existing. We had two alternative solutions for two of our blocks, one the ultrasonic sensor and the switch motor to water out. The ultrasonic sensor we may replace with a capacitive sensor to measure water levels. And another alternative solution was the switch motor to water out can be replaced with a gravity dispenser to reduce cost and make the design a bit easier.
My name is Hunter Mooney. I'm going to talk about the key blocks from our system block diagram. The first key block here being the ultrasonic sensor, this right here. It's called the HC-SR04. Just comes with the kit that we bought, the Arduino kit that we bought. So the measurement of water is the most important feature in our whole design. The ultrasonic sensor senses distance, so it's going to sense the distance of the water from the top of the cup to the bottom, and that's how we're going to judge how much water the users drank. Some other methods that we thought about were attaching a load sensor. So we put the cup on top of the load sensor, and then that way the weight change is what registers, and that's how we decide on how much water the users drank in. And another one was also a water level sensor. We ultimately chose against the water level sensor because we didn't want to get any of the wires wet and compromise them at all. So we chose this just to limit cost and complexity. The display is another key block. We were choosing between two separate displays, one being this one here. It's an LED display. So this one will be able to display letters as well as numbers. That way we can show the unit that the user has chosen. And this one is a lot simpler and easier to use. It's just a 7-segment display. This only shows numbers, but it is much easier to wire and hook up.
And our electronics.
Hi, my name is Shabir Hussain, and I'll start with the predecessor work. The first design we are looking at is from a YouTuber named TC Bipon. He has made a very simple and clean design. And the second design is from a website called Circuit Digest, which looks a little more complex, but the functionality of both the designs are very similar, as they both use an ultrasonic sensor to detect an object, the container in front, and allow the water to flow. And this is the basis for our project, in which we will add more functionality as to record the water outflow of water for the day. Okay, so the next is testing, which is one of the most important part of any project. The first testing is of the individual components to make sure that they're not faulty. And there are not any loose wires or open wires, so that can cause any short circuit. Next will be water pressure testing to make sure that the water pressure is not too low so that it takes a long time to fill the container, or not too high so that it can cause any spill when filling the container. Next will be the hardware testing, in which we'll combine all the component and make sure that they are working in the sequence we want them to. Next will be the leakage testing, which is a simple testing done with our eyes and hand to see or feel any wet surfaces. And the next will be the software testing, which will be the complete test of this project to make sure that the water is to make sure that the software is recording the outflow of the water for the day. And the last thing that I would like to mention that is that any changes or in the design or the functionality of this design may cause our method to change or our test to increase.
Okay, now here in front of me are the important dates for task completions. The first thing that we want to get done is finalizing our design so that we can really get things into motion. So that's why it's set for February the 6th. All the individual components tested, so that just means the sensors and all of that stuff, just so we know that they're all working and that that we know how to use the Arduino in conjunction with the sensors and displays. Reading week, that's when Christian wants to go over the 3D printing design. He's already showed an interest in wanting to learn how to 3D print, so he's going to do that. And then our encasings should be ordered by March the 1st. That should leave us with plenty of time for the 3D printed stuff to arrive. Water dispense testing and leakage testing kind of go hand in hand since they're both having to do with the water dispensers, and Shabir is going to be in charge of that stuff and the motors. The software design is long and strenuous, so that's kind of going to be all hands on deck. So we're all going to work on software design for a month or so. That's combining the motors and the displays and the sensors all into one, so that our prototype should be completed by roughly March 10, or the display and user interface, pardon me, and then by April 1st, all of the stuff should be combined and within that casing. That gives us time to get ready for our presentation. And yeah, that's pretty much it. That's the rundown of the Thirst Quencher. Thank you for watching.